Good morning, students. This is Shubhakar P, HOD of Department of ECE. In this semester, I am going to handle the subject. Name is Digital Electronics and Logic Design. In short, we can call it as De&Ld. In the last semester, we have studied the analog electronics. It is one branch of electronics. In this semester, we are going to study the another branch of electronics, that is called digital electronics. The subject name, it is digital electronics and logic design. That means we are going to study some of the fundamental things in the digital electronics. By using those fundamental and basic things, we are going to design some digital circuits. So it is named as digital electronics and logic design. In this complete digital electronics and logic design, we are going to study the behavior of some electronics circuits, specifically digital electronic circuits, and we are going to design some of the digital circuits. By having the fundamental knowledge of the digital electronics, we are going to design some digital systems or digital circuits. That is the main objective of digital electronics and logic design. It is the common subject for the electronics and communication engineering, electrical and electronic engineering, computer science and engineering, and information technology. That means it is one of the important and interesting subject in the BE. Whatever may be the branch, it is one of the important subject. It is a common subject for all the engineering branches. So, while you are studying the digital electronics and logic design, my request you to put some additional interest in the digital electronics and logic design. So in this video lecture, I am going to talk about the introduction about the digital electronics and logic design. And then after that, I am going to discuss about the differences or analog electronics versus the digital electronics. Then if you are good at the digital electronics, what the subject you are going to be studied very easily in the coming semesters. And after that, I am going to discuss about the syllabus, and I am going to give some of the introduction about the digital systems and analog systems. As I told, digital electronics and the logic design. In this subject, we are going to study some of the digital electronics devices. By having the knowledge of digital electronics, we are going to design some digital systems or digital circuit. This is only the main objective of digital electronics and logic design. So before going to in depth to the digital electronics and logic design, first of all, we should know what is a digital electronics. As we are aware of the analog electronics is a one branch of electronics in which the electronic circuits completely deals with the analog signals only. I am repeating the same point. Analog electronics, that means electronics will be broadly classified into two categories. If you take the electronics is a science which completely deals with the semiconductors. Electronics is a science and technology which completely deals with the semiconductors. The study of the current through the semiconductors is called the electronics. We have studied these things in the analog electronics. Electronics is a science and technology, and it is a study of current through the semiconductor. We have the various types of semiconductors. If you take any electronic device, it is composed with the semiconductor. It is composed with the integrated circuits. And the integrated circuit composed with the various semiconductors. So, as we know, the electronics is one branch of engineering which is a study of the current through the semiconductor in presence of the voltage, in presence of the magnetic field, in presence of anything. If a semiconductor is conducting the current, if you are studying that current, if you are noting down the behavior of that current, then that is called as electronics. That electronics will be two types. Electronics will be categorized into two types. One is analog electronics, another one is digital electronics. So we have discussed this analog electronics in the first sem only. Analog electronics, in which we have studied the diodes and transistor. Analog electronics is one branch of electronics in which we have studied the diodes and transistors. To the diodes and transistors, we have given the input signal is analog. Input signal is analog and the output is also the analog. So, analog electronics is nothing but it is one branch of electronics in which the circuits, in which the electronic circuit completely deals with the analog signals only. This signal is named as analog, and this is also analog. So I am recalling the concept of analog. Analog is nothing but analog signal is a one. A continuously varying signal is called analog signal. If you go back to the analog electronics, in the whatever we studied in the first sem, we studied the diode and transistor with respect to the analog signals only. Analog signals. If you go with the rectifier, rectifier is designed with a diode to which we have given the AC signal, that is alternating current, and it is a analog signal. And the output of this one is a pulsating DC. We have discussed this one. Input is an analog signal and output is also analog signal. An electronics which completely deals with the analog signal, input and output is an analog signal, then that is named as analog electronics. We have discussed these complete things in the first sem. So here analog, input is an analog signal and output is also analog signal. What exactly the meaning of analog signal? Analog signal is nothing but a continuously varying signal. Analog signal is nothing but a continuously varying signal. That continuously varying signal may be voltage or current. That continuously varying signal may be voltage or current. A continuously varying signal is called analog signal. The best example for the analog signal is nothing but it is a AC signal. That AC signal may be voltage or current. And if you go with the analog electronics, I am going with the analog electronics, that means it is an analog system, and to which I am giving the input signal is an analog signal. Analog signal is a one which is going to continuously vary. It is continuously varying with respect to the time. That is called analog. Then output is also analog. It is continuously varying with respect to the time. So we studied the behavior of the transistors and diodes by applying the analog signal. The output is also the analog signal. It is keep on varying with respect to the time. So if the input is varying, then the output is also varying in according to the input signal. If the input is varying, output is also varying in accordance with the input signal. And if you go with the input signal or if you go with the output signal, input and output is an analog signal only. Analog signal is nothing but it is keep on varying with respect to the time. Keep on varying with respect to the time, and this is called analog signal. In the output, we can have, if it is a output voltage, we can have infinite values. We can have the infinite values. From here to here, we can get the infinite values. We can have the one value is at the t is equals to 0. We can have the one more value is at the 0.1. We can have the one more value is at the 0.11. Like that, we can have the infinite values in the analog signal. So this is an analog signal, and we have been applying as an input for the circuit that is called analog circuit, and whose output is also analog, and that branch of electronics is named as analog electronics. All these things we have discussed in the analog electronics, that is in the first sem. I hope I am very clear that analog electronics is nothing but it is one branch of electronics in which the complete electronic circuits deals with the analog signals only. Input is analog signal and the output is also analog signal. Analog signal is nothing but a signal is continuously varying. Continuously varying is called analog signal. It is continuously varying, whose amplitudes are infinite, that are called analog signal. And these things we have studied in the analog electronics. Now we are going to study the digital electronics. As we know, the electronics is divided into the electronics can be classified into the two branches. One is analog electronics, another one is digital electronics. Digital electronics is one branch of electronics in which the complete circuit deals with digital signals only. Whereas in analog electronics, electronic circuits completely deals with the analog signals, whereas in digital electronics, the complete electronic circuits deals with the digital signal only. Then you may have the doubt, what is digital signal? What is the digital signal? You may have the doubt. A signal definition I am giving, a signal that may be voltage or current, which can have only two discrete values called digital signal. We are having a signal and which is having only two discrete values, then that signal is called a digital signal. Here it is having the infinite values. Here in analog signal, we are having the infinite amplitudes. Whereas in case of digital signal, we will be having only two discrete values. Only two discrete values. The best example for the digital signal is a square wave. If I go with the square wave, we can have only two discrete values. See, this is one amplitude and this is 0 and this is, for example, if I assume this amplitude is 1 and this amplitude is 0 and this amplitude is 1 and this will be 0. So that in digital signal we will be having only two discrete values, 0 and 1 only, 0 and 1. A system which completely deals with the digital signals. A system which completely deals with the digital signals, that system is named as a digital system. Input is a digital signal and the output is also the digital signal. Then that electronics is named as digital electronics. Then that system is named as digital system. I hope I am very clear. In case of analog system, whose input is continuous times, whose input is analog signal and the output is also analog signal. Analog signal is nothing but it is continuously varying signal. It is having infinite levels of amplitude, infinite amplitude levels. and it is deals with the completely analog signals only, and that electronics is nothing but analog electronics. In digital electronics, the systems completely deals with it. The electronics completely deals with digital signals, then that is called as digital electronics. Then digital signal is nothing but a signal which is having the two discrete values. That discrete values are 1 and 0. It is switching from 1 to 0 instantaneously. There is no delay. So that digital systems are very faster than the analog systems. Our digital electronics are faster than the analog electronics. If you are good at the digital systems, if you are good at the digital electronics and the logic design, and you are going to find very interesting things in the microprocessor and microcontroller, you are going to study, that is in the 5th sem. And if you are good at the concept of digital electronics, you are going to find very easy things in the DSP, that is digital signal processing, in the 6th sem. So that if you are good at the digital electronics, that will give you the basics of the digital electronics to study the microprocessor and microcontroller, which is there in the 5th sem. And again, if you are good at the digital electronic concept, and you can easily understand the digital signal processing, that will be there in the 6th semester. I hope I am very, very clear. Digital system or digital electronics completely deals with the digital signals only. In digital signals, we will be having the two discrete values. That signal may be voltage or current. We will be having the two discrete values only, either 0 or 1. Whereas in case of analog signal, we will be having the infinite amplitude levels. Here we will be having only two amplitude levels in case of digital signal, whereas in case of analog signal, we will be having the infinite amplitude levels. And this branch of electronics is named as analog electronics. We have studied in the 3rd semester itself only, and we are going to study the digital electronics in the 4th sem now. So this is here in the digital electronics. And if you go with the digital electronics, complete digital systems deals with the digital signals only, whose amplitudes are only two discrete values. And if you go with the semiconductor devices, like diodes and transistor can be designed to operate in the two states, that is saturation and cutoff region. Saturation can be treated as 0 and cutoff region can be treated as 0 and the saturation can be treated as 1. I hope I am clear. Here in the electronics, we will be using the diodes and transistors, and the diodes and transistor can be designed to operate in two states of operation. One is cutoff region, another one is a saturation region. In cutoff region, we can treat that state is 0. In saturation region, we can treat that region is 1. In that case, output voltages can have only two states. In that case, the output can have only two states or two values, either low or high. The 0 can be named as low and 1 can be named as high. So here I am designing the digital electronics, or a digital circuit, or a digital system. An electronic circuit which is designed to operate with the digital signals, then that is called digital system or a digital circuit. An electronic circuit that designed to operate for two states, either in cutoff or in saturation, either in low or in high, either in 0 or in 1. An electronic circuit is designed to operate in two distinct regions of operation, either in cutoff or in saturation, either low or in 0 or 1. then that digital system or the digital circuit is named as then that such system is named as a digital system or a digital circuit. In the entire syllabus of the, if you go through the syllabus of the digital electronics and logic design, that is in short we can call it is a De&Ld. The first unit is about the fundamentals of digital system, fundamentals of digital systems and some logic families. First unit we are going to discuss about the basic building blocks of any digital system and how these digital systems are realized by making use of the various logic families. That means what? We will be having some various logic families to realize the digital systems. And the digital system, we know that the digital system is a one which can be designed to handle with the digital signals only. A system which can deals with only digital signals, that is called a digital system or digital circuit. In the second unit we are going to study the combinational circuit. So that means what? Combinational circuit. In the digital electronics again we are going to classify digital electronics again classified into the two more types. One is a combinational circuit, another one is a sequential circuit. Electronics divided into two branches, analog electronics and digital electronics. Analog electronics completely deals with the analog signals, input and output is analog signal, and whereas the digital electronics deals with the digital signals, and these digital signals are having only two amplitude levels, 0 and 1 only. Input is a digital signal and output is also digital signal, and that electronics is named as digital electronics. And later on this digital electronics also divided into two branches. One is called combinational circuits and the digital circuit. That combinational circuits will be studied in the second unit and the sequential circuit will be studied in the third unit. This is sequential circuit. And coming to the fourth unit, we are going to study some data converter. For example, if I am having the data is in analog form, I wanted to convert that is into digital form. So that I require the data converter. Data converters which converts from the analog to digital and digital to analog also. How they are going to convert the data, one form of data into another form, we are going to study in the fourth unit. And the fifth unit is nothing but it is a semiconductor memories. How the data, how the digital data or how the binary data is stored in the semiconductor memories, we are going to study in the fifth unit. I am very clear about the syllabus. I hope I am very clear that I have explained the introduction about the digital electronics and the analog electronics versus digital electronics. What is analog electronics? What is digital electronics? What is analog signal and what is digital signal? And what are the amplitude levels in the analog signal and what are the amplitude levels in the digital signal? And the syllabus we are having the 5 units. First unit is basics of digital systems and some logic families. Second unit is nothing but it is a combinational circuit. It is one branch in the digital electronics. Digital electronics can be divided into combinational and sequential circuits. That combinational circuits will be studied in the second unit. Sequential circuits studied in the third unit. And if you have the one form of data, that is if you are having the analog form and if you wanted to convert into digital, or if you are having the digital form of data, if you wanted to convert into analog, and that will be the data converters. And we know that digital data has to be stored somewhere. By making use of the semiconductor devices, we are going to store that digital signals in the form of zeros and ones by making use of the semiconductor memory devices. This is about the complete syllabus of the digital electronics and logic design. And again I am continuing the what is analog system and what is digital systems. With this I am going to close this session. And what is analog system? Generally electronic systems are two types. We know that, and electronic systems are two types. One is analog system, another one is a digital system. Analog system are those in which voltage and currents were continuously through the given range. We know that. Here we are having the analog system. Assume that this is an analog system. Analog system or an analog circuit. Analog system or analog circuit to which we are giving a continuously varying signal. And based on the circuit which is used in the analog system, it is going to generate the again continuously varying signal only, that is analog signal only, so that signal may not be the same of the input signal, and it is like this. If you go with the example of analog system, the best example for the analog system is a rectifier. What is the function of rectifier? Rectifier is an electronic circuit which converts the alternating current into the pulsating DC. So it is keep on varying, and this is also keep on varying. So a system which completely deals with the analog signals is named as analog system. The best example for the analog system is the rectifier. You can take the one more example for the analog system, that is amplifier. Amplifier is an electronic circuit which increases the strength of the signal. This is an analog system to which I am giving the input signal is electrically weak signal, then output will be the strengthened signal. This is nothing but it is the best example for the analog system. Input is an analog system signal and output is also analog signal. A system which completely deals with the analog signals, then that is named as analog system. The definition of the analog system is very simple. Analog systems are those in which voltage and currents varies continuously through the given range. They can take the infinite values within the specified range. Amplitudes are infinite. Infinite levels of amplitudes we can get. The best examples for the analog systems, which are amplifiers, and rectifiers, function generator, electrical motors, etc., etc. The next type of the electronic systems are called digital system. The digital systems are those in which the voltage levels assumed to be finite number of distinct values. Each voltage level can actually a narrow band of voltages that can be either 0 or 1. The best example for the digital systems are a digital calculator and the digital computers. And here these digital systems are sometimes called as switching systems also. Here we are going with the block diagram of the digital system. For example, it is a digital system to which we will be giving the signal that is having only two distinct values of amplitudes. Output is also only two distinct values of output, then that is named as it is a digital system. The best example for the digital system, it is a digital calculator and digital computers. Here the digital systems are having the more advantages than the analog system, because analog digital systems have a number of advantages over the analog system, and these analog systems are now being permanently replacing by the digital system, and the digital systems are easy to design. Very important advantage of the digital system, that is digital systems are easy to design. These are very easy to design. Second one, advantage of the digital system, and in digital system we can store the data easily. We can store the data very easily, and we can get the accuracy and precision by making use of the digital system. And the digital systems are more versatile than the analog systems. Digital systems are less affected by the noise, and the reliability is also more in case of digital system. And even though the digital systems are having the many advantages over the analog system, but the real world is completely analog only. If you take any real world quantity, physical quantity, that is analog signal only. If you go with the temperature, it is analog signal, because the temperature is keep on changes with respect to the time, so that it is an analog signal. Even though digital systems are having the many advantages over the analog systems, but the real world is completely analog only. Even though the digital techniques have a number of advantages, they have only one major drawback, that is the real world is analog. Only the one disadvantage of the digital system, that is the real world is analog. Real world is analog. If you take the temperature, if you take the pressure, if you take the percentage of water in the air, that is keep on varies with respect to the time, so that everything in the real world is analog only, but the digital systems are having the many advantages over the analog systems. So with this introduction of the digital electronics and the logic design is complete. From the tomorrow, I am going to start the actual syllabus of the digital electronics and logic design. Thank you, students.